Okay, an airplane flies east from point A for 2 hours at a speed of 40. Another distance, speed, time. Goodness. An airplane flies east from point A for 2 hours at a constant speed of 420 until it reaches B. It then changed direction. Again, this reminds me of a boat question from many years ago where the boat changes direction. I don't even know if it's the same triangle again. It then changed direction by heading 20 degrees towards the south at the same speed until it reaches point C. The direct distance from A to C is that. The angle is that. How long to go from B to C? Well, first we'd have to get the distance B to C, I suppose. But if the airplane flies for 2 hours at a speed of 420 per hour, then it means this distance here is 840. So is it a cosine rule again? BC would be a cosine rule. 840 squared plus 1450 squared minus twice times 840 times 1450 times cos 8.57. 631.90, etc. The time is the distance over the speed. So that would be 1.5045, etc., hours, which is 90 minutes to the nearest minute. The average fuel consumption is 3.8 litres per second, and the fuel capacity of the plane is 100,000 litres. Show that the plane will be able to complete the journey from A to B to C and directly back to A again at a speed. Okay. So the total distance is 2 times 840 plus the 631.90. Which is 2944 kilometers if you want to round it to the nearest kilometer. The time is distance over speed. So if I just divide this by the speed of 420, that's 7 hours. That's 25233 seconds. And it uses 3.8 litres per second. So that is 95884 litres, which is just about less than 100,000 litres. The voltage is given by that. Find the period and the range. Let's put the calculator in radian mode. So the period is 2 pi over 120 pi. So that's 1 over 60. It's 60 hertz, I guess. And the range is from minus 110 root 2 to 110 root 2. Sketch the function where P is the... Sketch the function... Oh, yeah. Okay. I'm just going to do a super quick sketch. Voltage in volts, time in seconds. That's a 60th of a second. That's a 30th. That's a 15th. That's in between a 30th and a 60th. which is a 40th. Something's gone wrong here. No, no, it's not a 30th. Oh, sorry, that's wrong. It's half a 60th, which is a 120th. And then this is 1 over 240. And then that's an 80th. And it goes up, down, up. And that's at the top there at 1110 root 2. And then minus 1110 root 2 at the bottom here. Find the voltage at 6.67 seconds. That's easy. 110 times root 2 times sine 120 times pi times 6.67 seconds. And then the voltage would be 147.95 volts. Find one value for t when the voltage is 110. Give your answer in that form. Okay, so when would 110 equal, what's it, 110 root 2 sine 120 pi t. Okay, let's solve that. Divide by 110 root 2, sine inverse both sides. We get 120 pi t equals pi over 4. Cancel the pi's. And the time is 1 over 148 seconds. Let me double check that. 110 root 2 times sine 120 times pi times 1 over 480 is indeed 110. Find the rate of change at 2. Okay, so that's dv dt equals 110 root 2 120 sine 120 pi t, which is 2. Oh, sorry, not sine, cos. Derivative, forgot. And the 120 pi comes outside. That's a bit messy. So 110 times root 2 times pi times 120 times cos 120 times pi times 2 to the nearest unit. That would be 58646 volts per second. 110 root 2 pi 120 sine becomes cos 120 pi t. Okay.